My name is Mr. Pettit, and I'm so glad you've joined me today as we work through this lesson and uncover together proportions. Now, we're going to do a couple simple things today. Number one, we're going to work through the basics and we're going to define proportions. Proportions involve ratios, and oftentimes they involve variables. So we're going to work through that together, and we're going to uncover what a proportion really is. The second thing we're going to do today is we're going to work through an application problem. I think you'll enjoy this problem because it involves a real-world application that may or may not happen, and I think that we can have a lot of fun working through this problem and solving the equations in order to figure out our proportions. So, that being said, let's get started.
Alright, so let's take a look at what a proportion is exactly. As you can see, a proportion is when two ratios are set equal to each other. And the key word here is ratios. So I've got two ratios and I've used equal sign. I've set them on either side of the equal sign, so we've set them equal. So we have our proportion. Now you might say to me, Mr. Pettit, why are you using letters instead of numbers? Well, if you remember from the introduction, I said ratios or proportions could often use variables. And variables are nothing more than a placeholder. So you have to think of these as some unknown numbers. So these could represent, like A over B could represent miles, the number of miles per hour that a car travels, or the C over D ratio could be the parts in a plant that are made per cycle of the machine. So it's just it's the relationship of two numbers. You might even think of it in sports terms, the number of hits per inning in baseball. So it's just ratios. It's two ratios on either side of the equal sign sets up the proportion. So let's look at our problem. Now this could or could not be real, but I have used this, and this is Sally. Sally is a competitive eater. Sally can eat 6.5 hot dogs in 1 minute. How many hot dogs can she eat for each additional minute up to 5 minutes? So what do we know? Well, we know that Sally can eat 6.5 hot dogs in 1 minute. That is a ratio, right? So she can eat 6.5 hot dogs in 1 minute. That's how the two numbers relate to each other. Now, we don't know how many hot dogs she can eat for each additional minute. So we're looking at minutes 2 through 5. So what I did was I set up a table. I know that she can eat 6.5 hot dogs in 1 minute, but what I don't know are these numbers here. So I know that I want 2 through 5 minutes, but I want to know the values of the number of hot dogs she can eat in each additional minute, provided the proportion stays the same. So what I'm going to do is I'm going to use another variable. I'm just going to put x in for what I don't know. So let's just work with 2 minutes. So at 2 minutes, how many hot dogs could Sally eat? Well, we're going to set up our proportion. Our proportion looks something like this. 6.5 hot dogs, okay, this is our hot dogs, per 1 minute. This is our minutes here, hot dogs per minute. What we don't know is how many hot dogs per 2 minutes. Okay, this is our minutes. What I want you to see here is something very important. When setting up a proportion, you have to set up both values equally. So I've got my hot dogs on top and I've got my minutes on the bottom. If you don't set it up this way, then the proportion won't come out right. But you've got hot dogs on top and minutes on the bottom, so they're equal. Alright, so when we do this, we're going to use a method called cross multiplication. You may remember. Cross multiplication takes these two numbers and multiplies them, and takes these two things and multiplies them, the variable times the number 1. So that's going to look something like this. 6.5 times 2 equals 1 times x. Now, 1 times x we know is just x, because anything times 1 is itself. But 2 times 6.5 equals 13. So x equals 13. What was x? X was our mystery number, the number of hot dogs we were looking for. And so we just plug that back into our table. Instead of x, we put in 13. All right, so we want to know 3 through 5. Well, let's set up our proportions the same way. The only thing that's changed is our number of minutes here that we're looking for. Our original proportion hasn't changed. It's still 6.5 to 1, but our number of minutes has changed, right? On how many minutes we want to know. We want to know how many hot dogs per 5 minutes, per 4 minutes, per 3 minutes, right? So we're going to solve these in the same fashion. We're just going to cross multiply this 6.5 with 3, this x with 1, and it's going to come up like this. 6.5 times 3 equals 1 times x. 19.5 equals our x, okay? So we're going to do that for each equation, and we're going to get our values for x. We're going to cross multiply. We're going to do this here and this here. We're going to do this here and this here. We're going to multiply those numbers. We're going to cross multiply, and our answers come up like that. So we plug those answers back into our table. Here's 3 through 5. Those are the answers that we came up with. And we can see that, that Sally can eat 32.5 hot dogs in 5 minutes. Well, you may have noticed a long time ago that we're just increasing these values here, right? We're just increasing each value by 6.5, and that seems fairly simple. But if you had different values, I wanted you to see what it would take to use the proportion. Well, let's look at this just a little bit differently. How long would it take Sally to eat 52 hot dogs? So now we know the number of hot dogs, but we don't know how long. We don't know our number of minutes. So if we look at our table, we would put x in for our number of minutes instead. We already know 52 hot dogs. So we set up a proportion like this. I've changed this. This is the number of minutes. I've still got minutes under the number of hot dogs, okay? But I just put our mystery number in for what we don't know. So if we cross multiply this, we would get 6.5 times x, 52 times 1. We get something that looks like this. Well, how do I get this x by itself? See, I need to get rid of this 6.5. Well, because we're multiplying 6.5 times x, we need to divide. We need to use the inverse operation. When we divide, that 6.5 divided by 6.5 is going to go away because that equals 1, and 1 times x is just x. Well, 52 divided by 6.5 is 8. So x equals 8. So when we put that back into our table, our 8, remember, was our mystery number, and we're looking for the number of minutes. So 8. So Sally can eat 52 hot dogs in 8 minutes. So we're going to solve these equations in the same fashion. All right? We're just going to cross multiply. We're going to cross multiply this 6.5.
Well, now that we've worked through that problem together, it is my hope that you've learned some new things and possibly recapped some old things, such as variables and ratios and how they interact with proportions. So what is a proportion? Simply two ratios set equal to each other. When you're working through the proportion problem, make sure that you make a table so that visually you can see those numbers side by side. Set up your equation properly. This is probably the most important of all. You've got to have the same values on the top of your ratios as you do on the bottom of your ratios. So if you remember, we put our hot dog values on top, we put our minute values on the bottom, and they were equal on both sides. Then you've got to solve the equation. Simply solve it for your variable. Whether it be x or a or b or whatever it may be, solve for your variable. Get your answer. Then fifth, complete the table. Take your answer, put it back in the table so that you can refer to it again, and so again you can see it visually. Thanks for watching. I hope to see you again soon.